Particulate of matter. So as we all know, it's the first and foremost topic in our syllabus. When a solid is heated, so this diagram is kinetic particle theory. So this diagram clearly telling us how the particles are placed, how the particles are arranged in a container or in a space. So how these particles are arranged? So these particles are arranged according to their state of matter. And we have 3 states of matter, which is solid, liquid, and gas. And solid, of course, it will be closely packed. They vibrate. They don't have enough space in between, right? And liquid, they will be arranged a bit further compared to solid. They will have tiny spaces in between the particles, and then when heat is applied, they might move further away, and then where gas will come into picture. And then when gas coming into picture, the space between the particles will be more, and their movement will be free. So from your solid to gas, it is all involved. How they move, how fast and how slow they move, and when they move. So whenever there's a question regarding kinetic particle theory, where it involves state of matter, we always have to put in mind that we have few things to tackle, which is how they move. Basically, their movement. So we have to focus on their movement, how they move. Whenever temperature is applied, how they move. So this particular topic is very much related to your chemical reaction as well. So remember, chemical reaction, we will learn rate of reaction. When we are learning rate of reaction, we always will learn all the 5 factors which affects the rate of reaction. What are the 5 factors? Temperature, pressure, concentration, total surface area, and also catalyst. These are the 5 characteristics of 5 factors which will affect rate of reaction. So this rate of reaction is very much related to kinetic particle theory. And this kinetic particle theory, their movement, their vibration, and their performance is very much related to collision theory. So if you focus only particulate of matter, only not a big thing. I know solid, liquid, gas, and I just have to know their transformation, their change of state of matter. No, this one will relate to your rate of reaction and your chemical reaction and chemical energetics. How energy is affected by all these 5 factors, and because of the movement of the particles, how energy effect, how movement effect, and how collision theory will affect with all these 5 factors. Understand so far? Right. So again, this is specified solid, liquid, gas, their characteristics, like how they are arranged, and they cannot be compressed. Solid cannot be compressed. We all know, like I cannot compress this pointer, like with my how hard I press also, I couldn't press this because it's a solid matter and their particles are very closely packed together. Okay, let's say if I am squeezing a bottle of water, I could make it. But if let's say the bottle is closed very tightly, I could not do that too. With a high pressure, let's say I put under a car tire or what, let's say the car tire is going on top of the water bottle, maybe that very high pressure might affect the water bottle, the liquid particle, but then not very minute pressure. We need more pressure. Okay. And finally, gas. Gas, they will always take up the shape of their container, because if let's say we might have gas in the room here, like we have air in the room, but we don't know where is it located, like is it like very far apart or very pointed in one point only, or at the back only, or near the aircon only, we won't know like how the air particles are arranged. So they are all over the place. So these are the main examples where it will talk about solid, liquid, and gas. For the questions related to this kind of diagram, there are questions asked before how this diagram will be drawn, how solid, liquid, and gas will be arranged the particles are arranged. So this kind of question, this diagram will help you to draw. Okay, heating curve. Heating curve and we have cooling curve. Heating curve and cooling curve will tell us how a state of matter is changing from one state to another state and from one state to another state in a reversible way. So we have forward and backward way. Understand? So heating curve. So once melting is start, the temperature stays. So if you see from the first minute, before the first minute, going up to the zero temperature, right? So the ice is warming up. So basically, heating curve is I am heating something very cold to become steam. Cooling curve, steam to solid. So heating curve will always go like this and your cooling curve will come down like this. So if let's say in exam, they are asking, draw the heating curve and cooling curve in the same axis. How are you going to tackle it? Basically, as you can see, the graph is ending on top and this graph is starting from top and then ending at the bottom. So how your top part of the graph will be, it will be like a V, a reverse V shape. So your heating curve will go this way, your cooling curve will come down the other way. It's like a staircase. But then in each and every step of the staircase, the state of matter is changing. So how the state of matter is changing? If let's say I am boiling, I am heating the ice cube. So ice is warming up and then ice is melting and then the melted ice will remain melted as liquid for some time and then the water starts to boil when I'm increasing the temperature more and more. So that's why if you see your x-axis and y-axis is time and temperature. So why time and temperature? Temperature is one of the factor that will affect the rate of reaction. So when the temperature is being increased, so your state of matter is changing from ice to steam. So finally, water vapor getting hotter. So water vapor getting hotter in the sense of your water is already boiled, there's already steam, and already steam is coming out from the particular container where I'm heating the substance. Cooling curve, I want to leave it aside. Leave it aside. And then what I'm going to do, I'm going to decrease the temperature. Leave it aside at room temperature first. Let me reduce the temperature. Let me reduce the state of matter. So from steam, it will come back to liquid again. And then from liquid, it will go back to solid. So it's going to freeze again. So that's how it's going to work. Okay, sample of questions. This question is about state of matter. If let's say in particular question, you have a table like this. So how are you going to do it? So when you have a table like this, they're asking for the particles random movement, and particles regularly arranged. So they are asking you to tackle their movement and also their arrangement. So at first, you have to mention that whether the particles will be touching or not. In gas, we obviously know the space is very much bigger and they won't touch each other. One thing. Second, in liquid, they will touch, but the space will be very minute. Third, in solid, they will be touching very much closer because they are very much closely packed together. Next, random movement. Random movement for gas, of course, I know randomly will move. So there's no restriction for them. As long as they have bigger space, they will move everywhere. And then for liquid, random, although they're asking random movement, although liquid will not move as random as gas, but they can move. So what they're going to do? They will move. And then for solid, for random movement, of course, you cannot justify that solid particles gonna move randomly. So that answer is totally a no. And then finally, regularly arranged. Arrangement, of course, regular arrangement only applied for solid, not for liquid, not for gas. Understand? Okay. They're asking here, boiling and evaporation are two ways in which liquid changes into a gas. So liquid changes into a gas in the sense of I'm boiling the liquid. So here they didn't tell me clearly that they are boiling the liquid. They are just saying the change of matter is from liquid to gas. I must be able to understand boiling is going on. So when boiling is going on, you should be able to understand. When boiling is going on in your heating curve, your water boiling will be at the before the 3rd minute and up until will maintain up until after the 7th minute. And water boiling, the temperature going to be 100 degrees Celsius. And that's common. That's norm. Cannot be changed. So if let's say they are asking here, for liquid changing to gas. Okay, describe the differences between boiling and evaporation. Boiling is the process. Boiling is the process which is going on. But then evaporation, you cannot see the process clearly sometimes. Boiling, I can see. Boiling happens at a specific temperature. Evaporation, I cannot set the temperature yet. So what is the difference? Boiling has the fixed temperature. And boiling has bubbles. While evaporation, I cannot see because it evaporates. It just disappears. Consider it is disappearing. So I cannot see the differences. So that's why the differences between boiling and evaporation. Boiling, the changes I really could see from my naked eyes, but then not evaporation. So what could be the answer? Boiling happens at a specific temperature and boiling has bubbles, right? And then name the change of state when a gas become liquid and solid become gas. So if you notice here, condensation, freezing, all these are the process, and also here, boiling, melting, and vaporization is one of the process. And here they are asking gas becoming liquid. Gas becoming liquid is what curve? Heating curve or cooling curve? So it must be cooling curve. So condensation. And then solid become gas, sublimation. So this one you must remember the whole process. Remember, there will be a process where from solid, liquid, gas. And we have arrows where it will signify the change in matter from top to bottom. So that's where we have to identify which process is which, named as which, right? If let's say it's becoming hot to cold, condensation. If let's say solid to gas, it's sublimation. Okay, solid to gas, it will be undergo melting first because solid already ice cube, and then it is undergoing melting process, and then it will become liquid, and then from liquid it will become gas, boiling, and then but if let's say solid straight away becoming gas, so it will be always a sublimation process. Good. Okay, here they are asking, this is a cooling curve, and they didn't mention to you that it is a cooling curve. They are just saying gas is cooled. So you supposed to understand this is a cooling curve or heating curve. So from the word itself, gas is cooled, I must be able to understand this is a cooling curve. And then the cooling curve, the change of state of matter from A to B. Name the change of state. So they are asking the process name. They didn't ask what is the change of matter. So they didn't ask there whether I'm changing the vapor or the gas steam to liquid to solid, whether I'm changing that or what kind of process I'm using. So my answer is supposed to be what is the process I'm using, because they are asking for name the change. So when they're asking for the name the change, then I have to mention it is condensing. So no matter if let's say, how come teacher the question so long like that? So how am I supposed to know whether my answer will be short, one answer, two answer, or three answer, or a whole particular sentence? It all depends on the marks provided. So the particular marks provided for this kind of question is just 1 mark, because clearly it's just one word. You cannot explain. If let's say they are asking you, name the change of state taking place in A to B, explain. If let's say this kind of wording is there, explain. So the explaining part is asking you, clearly asking you that, okay, name the change first, condensing. What will happen near the condensing? The temperature will drop, right? From steam to liquid means the temperature is dropping, the temperature is becoming room temperature, and then the temperature is dropping, the particles arrangements are differentiating. How it's differentiating? Because in gas, the particles are arranged very far apart. But then in liquid, the particles are going to be arranged with a very, very small space in between. Right? So when this is happening, you have to mention like how the gas of the state of matter is happening, what is the process, and how the particles are changed. Good. So if this question, particular question, name and explain, you have to mention the name of the process and explain how the process will go on. Whether the temperature changing, the particles movement are changing, the particles arrangement are changing. So all these are acceptable answers. If let's say they didn't ask only name, there is just one more question. Right? If let's say the same question asked, what is the state of matter at A and B? So you're supposed to mention what is the state of matter. So as you can notice here, gas start to condense, condensation complete. So when condensation complete, it's already become liquid, right? So that particular process, the steam is still there. And then your liquid is coming down already. So from R to S, that's where your liquid is coming down. So from Q to R, your condensation process is still going on. And then it is just stopped by there. And then it's just stopped at R. So when the condensation process is going on, it is the process where it is becoming liquid. So at R, it's already become the condensation complete. It has already become liquid, and then the liquid is coming down and starting to freeze. That's how the answer supposed to be if let's say they are asking what is the state of matter, like what is the particular matter, whether it's liquid, gas, or solid, right?